Have you ever wondered how a ship seems to vanish from the screen, only to reappear miles away? Or how massive cargo vessels avoid colliding in some of the busiest shipping lanes on Earth? Behind that invisible choreography is a powerful but often misunderstood system, AIS data. In this video, we're pulling back the curtain on real-time vessel tracking and revealing how this technology keeps our oceans moving and our ships safe. For anyone working in maritime or simply fascinated by the sea, understanding real-time vessel tracking is no longer a luxury. It's a necessity. From ship captains and fleet managers to port operators and defense analysts, AIS data underpins safety, logistics, and even national security. If you've ever struggled to make sense of vessel plots on a screen or wondered how those signals translate into decisions on the bridge, this is your definitive guide. AIS stands for Automatic Identification System. At its core, AIS is a ship-to-ship and ship-to-shore broadcast system. Vessels equipped with AIS automatically transmit key information about themselves over VHF radio frequencies. The original purpose was safety, to reduce the risk of collisions by giving mariners an accurate, near real-time picture of traffic around them, even in poor visibility or heavy congestion. Not every vessel at sea uses AIS in the same way. Large commercial ships, tankers, and passenger vessels above certain size and voyage thresholds are generally required by international regulations to carry AIS and keep it active. Smaller craft, fishing boats, and leisure yachts may use AIS voluntarily, or not at all, depending on local rules and cost. That's why your screen may show a busy array of big ships, while many smaller boats remain invisible to AIS-based systems. Each AIS message is like a compact digital business card a vessel sends out again and again. It typically includes the ship's identity, position, course over ground, speed, navigational status, and sometimes details like ship type and dimensions. This information allows surrounding ships and shore stations to calculate relative movement, closest points of approach, and potential collision risks, all in near real time. AIS transmissions aren't constant streams of data, they're bursts. Fast-moving or maneuvering vessels may broadcast several times per minute, while slower or anchored ships report less frequently. This adaptive timing keeps the radio channels from becoming overloaded, while still providing enough updates for accurate tracking. That's why a rapidly turning ship seems to update more often on your screen than one drifting at anchor. When a vessel broadcasts AIS data, the signal is picked up by any receiver within range. That includes other ships, but also shore-based AIS stations placed along coastlines, ports, and strategic choke points. Over VHF radio, typical coverage ranges are tens of nautical miles, depending on antenna height and conditions. These receivers collect the messages and feed them into larger networks for processing and display. For open ocean tracking, shore stations aren't enough. That's where satellite AIS comes in. Specially equipped satellites listen to the same AIS signals, but from orbit. They capture broadcasts over vast regions and relay them back to ground stations, extending AIS coverage far beyond coastline limits. This is how many global vessel tracking services show ship positions in the middle of the ocean, far from land-based receivers. Once AIS messages are received, they're decoded, time-stamped, and merged with other data sources. The system calculates each ship's position, heading, and speed, then plots them on digital charts. Additional layers like bathymetry, shipping lanes, and traffic separation schemes help turn raw coordinates into meaningful situational awareness. By the time you see a vessel symbol on a screen, it has already passed through multiple layers of processing and filtering. For mariners on the bridge, AIS appears as symbols and data overlays on electronic charts and radar screens. Each target can show its identity, course, speed, and sometimes its intentions. This helps officers quickly identify risk ships, confirm visual sightings, and predict how traffic will evolve over the next minutes or hours. AIS doesn't replace radar or the human eye, but it adds a powerful layer of context to every decision at sea. One of AIS' most valuable roles is collision avoidance. By showing real-time courses and speeds, AIS helps mariners anticipate where ships will be, not just where they are now. Using tools like closest point of approach calculations, crews can identify developing risks early, adjust course or speed, and communicate intentions with nearby ships. The result is a safer, more predictable flow of traffic, especially in narrow channels and congested approaches. Beyond individual ships,
Between the
AIS is a
nations of
backbone for
Indonesia,
vessel
Malaysia,
traffic
and Singapore.
services. Port authorities and
Together with the
coastal
Strait of
traffic centers
Malacca,
rely
it
on
is a
AIS
maritime
to monitor
corridor of over
traffic
400
density,
nautical
enforce
miles in
speed
length.
limits, manage pilotage schedules, and coordinate safe passage through critical waterways. By seeing the full picture, not just one ship at a time, these centers can prevent congestion, reduce delays, and respond quickly to developing hazards or incidents. If you've watched online vessel maps, you've probably seen ships suddenly vanish, then reappear far away. Often, this isn't magic or foul play, it's coverage. Outside the range of shore stations or under poor radio conditions, AIS signals simply aren't received. Until another receiver, maybe a satellite, picks up the next transmission, the tracking system has to interpolate or go blind. That's why position updates may jump or freeze, especially in remote areas. Sometimes ships go dark on purpose. While regulations generally require certain vessels to keep AIS on, there are exceptions for security or safety. In other cases, ships may switch off AIS to hide questionable activity, avoid scrutiny, or evade sanctions and inspections. These intentional dark zones are red flags for analysts, regulators, and security agencies, prompting closer investigation and correlation with other data sources. For ports and logistics operators, AIS is more than a safety tool, it's an efficiency engine. By tracking inbound ships long before they arrive, ports can plan berth assignments, tug allocations, and crane operations with precision. Logistics teams use AIS-derived ETAs to optimize truck arrivals, warehouse staffing, and cargo handoffs, shaving hours or days off turnaround times and reducing costly idle periods. Fleet managers rely on AIS data to monitor vessel positions, speeds, and route adherence in real time. Combined with weather and performance data, AIS helps them choose more efficient routes, detect unexpected deviations, and benchmark fuel consumption across the fleet. Over time, patterns in AIS tracks can reveal where operational changes or maintenance investments will deliver the biggest payoff. Security agencies and compliance teams use AIS as a powerful early warning and investigation tool. By tracking vessel movements around sanctioned ports, embargoed regions, or sensitive maritime borders, they can spot suspicious patterns, unusual loitering, ship-to-ship transfers, or frequent dark periods. AIS isn't proof by itself, but it provides the starting point for deeper checks on sanctions evasion, smuggling, or other illicit activity. Illegal, unreported, and unregulated fishing is a global challenge, and AIS has become a crucial tool against it. Analysts watch for vessels that switch off AIS near protected areas or frequently cross boundaries into restricted zones. By comparing AIS tracks with fishing grounds and marine protected areas, authorities can identify likely offenders, direct patrols more effectively, and build evidence for enforcement actions. Smugglers and other bad actors have learned to manipulate AIS. Tactics include false identities, clone positions, and impossible jumps in location. These tricks aim to confuse tracking systems and disguise real movements. Advanced analytics, however, can flag these anomalies, such as repeated appearance of the same vessel in two places at once or tracks that defy physics, prompting deeper investigation and cross-checks with radar, imagery, and human reports. Despite its power, AIS is not a replacement for radar or visual lookout. It depends on other ships transmitting accurate information and on receivers actually picking up those signals. Small boats without AIS or vessels in shadow zones may be completely invisible on AIS-based screens. That's why international rules still require proper lookouts and radar use. AIS is a supplement, not a standalone safety shield. AIS data is only as good as the information entered and the equipment maintained. Incorrect ship dimensions, wrong call signs, outdated destinations, or misconfigured transceivers can all lead to misleading displays. Human error at setup, poor maintenance, or deliberate misreporting can degrade data quality. Skilled users always treat AIS data critically, cross-checking with radar, visual bearings, and seamanship judgment. Several myths around AIS. It does not guarantee that every ship is visible, it does not automatically prevent collisions, and it does not always show perfectly accurate positions. It's also not inherently encrypted. Standard AIS is meant to be open and widely receivable. Understanding these limitations helps prevent complacency and reinforces that AIS is a tool, not a magic shield or a secret tracking weapon. When you look at an AIS target, focus first on what matters most for safety: position, course over ground, speed over ground, and closest point of approach if available. Then consider ship type and length, which affect maneuverability and stopping distance. Destination and estimated arrival can help you anticipate intentions. Training yourself to pick out these key elements quickly turns a sea of data into a clear mental picture of the traffic situation. AIS becomes far more powerful when used alongside other tools. Combine AIS with radar, visual observations, depth soundings, and up-to-date charts. On shore, analysts merge AIS with weather systems, satellite imagery, and port databases. This layered approach creates robust situational awareness, compensating for the weaknesses of any single data source and reducing the chance of nasty surprises. Thank you for watching the video. Please subscribe, like, and push the bell button if you like the video.